So good morning students. So this is Gnana Saravanan S. So we are dealing about medical electronics. Before going into today's session, let's have a review of or a recap of what we have seen so far. So we started with why medical electronics is required, where medical electronics is playing a role in changing the today's scenario. So then we saw the origin of biopotentials, how the voltage gets generated inside the body. So we saw the cellular structure and the ionic movements, and then ionic current is then converted into electronic current by the use of electrodes. Then these signals were picked up by bioamplifiers and brought to a particular level. There are different types of bioamplifiers, we have seen that. Then we saw about biomedical recorders, different biomedical recorders, ECG, EEG, EMG. We have done this to the enough extent. Then we stepped into second unit where we saw about assisting device. The first assisting device which we saw was pacemaker. The second one is defibrillator, we are seeing. So we saw why pacemaker is required, what are the types of pacemaker. So we had internal pacemaker, external pacemaker, and so on. So then we stepped into defibrillator. So this was our yesterday's title. So we saw DC defibrillators and AC defibrillators also. Why defibrillators is required if you ask? So whenever there's a problem with sinoatrial node and that situation happens rarely, so instead of going for pacemaking, so we will try to provide a shock. So that counteract is called as defibrillation. Generally, fibrillation means the heart will shiver or quiver to function. It will struggle to function. So to reset it, we make a counteract, which is called as defibrillation. The circuit which does it is called as defibrillator. There are two types of defibrillators. So one is DC defibrillator and the other one is AC defibrillator. So the only major difference is the operating voltage. If it is a direct current, we call it as a DC defibrillator. If you make use of alternating current, it is called as AC defibrillator. Both has its advantages and disadvantages. We have seen it yesterday, right? So in today's session, we'll see DC defibrillator with synchroniser. So as the name indicates, you know what is DC defibrillator. Defibrillator is a circuit that is going to provide a shock to the heart, which is of 400 to 700 volts. So that is a direct current. So DC defibrillator we have dealt with yesterday. Now what is synchronizer? Synchronize means get along with something. So even you would have seen this in mobile. So you would like to synchronize the contacts and everything, right, to the cloud. So now this DC defibrillator is going to get synchronized with something else. So what is that something else is what we are going to see, right? So why synchronizer? So why synchronizer? Why, with what we are going to synchronize? So that's the question. So the hint is called as cardioversion. So cardio is a medical term. I've already told you. So cardio means heart, right? So cardioversion means in the heart activity there is a specific point, or in the ECG signal there is a specific point. So in the PQRS waveform. So in which when you apply the shock, means defibrillation shock, the success rate is more. So that specific point is called as cardioversion point. So it is simply in an ECG waveform, in an irregular ECG waveform, not proper ECG waveform. So now the patient is suffering with fibrillation, that is atrial fibrillation, the atrium is struggling to pump. So in that there is a specific timing, like there is a specific timing when fibrillation starts. So at that particular point, when you try to give the shock, then it works out. So this, they have found this cardioversion by trial and error with thousands or millions of samples. They have found it out. So that cardioversion point. So the thing matter here is at cardioversion point, you need to apply the shock. So the AC defibrillator and DC defibrillator was manually operating. So the doctor was trying to keep the shock to the patient randomly. Whereas this one is an automated one where it monitors the ECG, and at a particular point, means it monitors the irregular ECG, and a particular point when the fibrillation has happened, at a particular exact timing, the shock is being given. So that's when they do so, then the survival rate is more. So we are going to synchronize with the irregular ECG waveform. So that's the point or agenda here. So here you can see that there is a patient, the pads has been kept fixed, and there is something called as cardioversion machine. So cardioversion pads is fixed. So this will automatically monitor whenever fibrillation comes, irregular ECG waveform comes. This automatically activates and gives a shock to the patient, and so the patient's heart will become normal. So that is how it works. See, the function of the synchronizer is to determine the placement of discharge at a particular point. So this is what I told. So that is the only agenda of synchronizer here. Other than that, it is simply a defibrillator, DC defibrillator. Only thing is that you tend to make it automated. So did I make it clear? So it is an upgraded version of, or an automated version of defibrillator. So the overall operation, if you see, we need ECG waveform, regular ECG waveform, right? So from there, where it is going to happen? It's going to go to cardioversion detector. So we need to finalize when we need to apply this shock. So once we are applied, means we found out when we need to apply the shock, what is the next one? We need to activate the defibrillator, and then from defibrillator the shock goes to patient, as simple as that. So this is one line operation. But when we go to the block diagram, actual block diagram, there are some more blocks. Let's see it. So this is the actual block diagram. So here you can see that there is a patient, right? So in this patient, the paddle or the electrode, here the shock is being given. So we call it as paddle. It's a simple medical term. So the paddle is connected, always connected to the patient. So the paddle is connected to the discharging unit. So from the discharging unit, the high voltage is going to come. So this is a normal defibrillator. You can see that to the discharge circuit, there is a red control signal comes. I have made it as a red color so that you can have a difference. So whenever the control signal comes, the discharge unit is activated and it gives a high voltage current. So that is defibrillation. Now when to give this control signal is decided by this microprocessor. So to this microprocessor, you can see that the ECG signal is always given. So the ECG signal, it is analog in nature, so it is converted into a digital by A to D converter, and then it goes to the microprocessor. So instead of a computer, we make use of a microprocessor, or it can be even a microcontroller here. So the microprocessor processes the ECG waveform, it compares with the threshold or with the reference. Whenever the irregular pattern comes, it starts working, and at a particular point, it supplies the control signal. Through any port output, it supplies the control signal. Once it supplies, the discharge unit is activated, it supplies the high voltage, that's it. So the shock is being given. Now, as an additional feature, you can see that from the output, means transformer, there is a sample current being taken. It is also converted into digital and given to microprocessor. This unit is just for display purpose, because there is a display also where it displays how much voltage is supplied as a shock to the patient, what is the energy being supplied to the patient, and so on. So this is an additional feature, where this one is the mandatory feature. So this is going to be the synchronizer. So in the previous one I simply said it like cardioversion detector. So it is actually a microprocessor here. So a microprocessor does all the options. So means all the activities, right? So this is the general DC defibrillator with synchronizer. So did I make it clear? Hope I made it clear. So next title today is we'll go for implantable defibrillator. So we saw AC defibrillator, DC defibrillator with synchronizer. Now we are going to see implantable defibrillator. So all that we have seen so far, right? So far was external defibrillator. You can see that the cardioversion machine, defibrillator, everything lies externally. So in this there is DC and AC. So when they went on for DC, then people started thinking, why not replace it inside? So that is how implantable defibrillators came into picture. You can see it's simply in this much of size. So that is what is here. So like pacemaker, internal pacemaker, this is also placed at the shoulder. So before going into that, the question is, Why implantable defibrillators is required? So whenever, it's very simple, whenever the patient will have this fibrillation very often, then we need to go for an implantable defibrillator, because suddenly fibrillation comes, then you need not run to the hospital. Anything can happen on the way. So for a permanent damage of nervous systems or fibrillation conditions, we will always go for implantable defibrillators. So that's the only reason, like implantable pacemakers. This is the reason for going for implantable defibrillator. So like pacemaker, I showed you the size of it. Right? So it is only this much of size. So this is also placed on the right shoulder, just below the right shoulder. So now there will be a question, why just below the right shoulder? Maybe the one genuine reason is only in that place you have some space where you can place it, or even the nerves, you get the nerves which goes to sinoatrial node. Maybe that's the reason. So it is placed exactly in the place which we chose for keeping implantable pacemaker. So in the same way, how we connected to implantable pacemaker, this is also connected to the vein leading to the heart. So through the vein, the shock is being given. So this is implantable defibrillator inserted inside. So the electrodes goes so right after so whatever. So this is going to place a shock whenever is required. So there are some few conditions when we go for implantable. So it's similar to pacemaker. There is only one thing, right? So it should be highly reliable. Reliability means trustworthy. So you cannot operate and take it again and again and program it or malfunction. Malfunctioning cannot be allowed. So that itself kills the person. So it should be highly reliable. The second one is battery. So once you place it inside, so you should forget it for next 15 years. So it should have a long battery life. Then the next one is biologically inert, means it should not react with biological fluid. So biological fluid. The next one is, you see, this is a synchroniser. So it needs external programming. So the doctors or the engineers, when there is a necessity to reprogram it or fix something, so we need not operate and take it outside, so we can program it from the outside. So support of non-invasive. Invasive is a medical term again. Invasive means operated. You cut the and do something. So that is invasive. So here non-invasive means you don't touch the person with a knife. You keep the person outside and you operate from the remote. So that is non-invasive programming. And about battery life, means battery lifetime. So nowadays it comes to lifetime. Lifetime means 15 years, right? So right from mobile plan 15 years or life sentence, it is 15 years. So now even the defibrillators comes with 15 years of life duration. Now this is the block diagram. So you can see that this goes to the shock leads where veins. So output switch, so it's an electronic switch. Whenever the signal control signal is given, so it is open, so the high voltage goes to the shocks. So when to give the high voltage depends upon the defibrillator control. So that's control unit 2. The entire system is, you know it, already I told that synchronizer itself, there is a microprocessor. The entire unit is operated with the microprocessor. This is the brain of the entire thing. So the microprocessor decides when to give the shock. So that depends upon cardioversion, right? So to support this microprocessor, there is RAM and ROM. So ROM is for BIOS setup. So for the microprocessor to run initial programs, operating systems, you need a ROM. To operate with the data that is being got, for example, it needs to analyze the ECG signals and it needs to decide when is the cardioversion. So for that there is a RAM which is needed. So that's why it is a RAM and ROM. So this is memory unit. So system control. So this is for programming. Whenever you need to reprogram, so you can do it from outside. So like hacking a system, you have some codes through which you can access this microprocessor, operate it, or change this program, reset it and do whatever. So this microprocessor through its control bus, it gives a signal to defibrillator control. So from there, whenever the signal goes, the output switch is open. So the high voltage is going to the shock. That's how fibrillation happens. And there is low voltage supply also. So this is for the microprocessor, obviously, and RAM, ROM, and system control. So it needs to operate 5 volts. So that is why you have a low volt operating section and also high voltage operating section. So this is called defibrillation. So this is the block diagram of internal defibrillator. So you can see the same thing, right? So now we have an activity that you need to discuss. In yesterday's class, I asked you to design a simple shock circuit. I gave a clue that even in your mosquito bag there is a similar shock circuit. Now you need to upgrade that. So that is today's agenda. So it needs to deliver the shock at every 5 seconds. Means I am making it a programmable, right? So that similar one is what happens in implantable. At particular point called as cardioversion point, it supplies a shock. So that's what you need to do. So I'll give you a hint also. So doing it is very simple. You need to have an adjustable multiplier which gives the total time period is 10 seconds. So every 5 seconds you have 5 seconds on, 5 seconds off. So every 5 seconds you have a signal, means a trigger pulse. So that is given to the shock circuit. So the shock circuit is being operated at every 5 seconds. So that's the agenda. It's very simple. So this is your starting in EC2. This you did it yesterday. You mingle these two, you get this one. So as simple as that. See you in next class. Thank you.